Hi, Chuck Huber here for the Stata YouTube channel. Today I'd like to show you how to test the equality of survivor functions across groups using nonparametric tests. Let's open some example data from the Stata website by typing webuse drug tr, and we can see that we've opened a data set that contains patient survival data from a drug trial. And if we look in the variables window, we can see that the underscore variables have already been created using the stset command. And if we'd like to see the survival attributes of our data, we can type stset without any options and press enter, and now we can see the survival attributes of our data. So let's begin by clicking statistics and scrolling down to survival analysis, and then we're going to select summary statistics tests and tables, and then we're going to select test equality of survivor functions, and this will open the STS test dialog box. So at the top of the main tab, we can select the variable that defines the groups that we would like to compare. So in this case, I'd like to test the equality of the survivor functions for subjects who took an experimental drug and subjects who did not. So I'm going to select the variable drug in this window. Next, I can select which test I'd like to perform. So I'm going to begin with the log rank test, which is the default test, and it's possibly the most popular as well. So I can simply click submit. And if we look at the results, we can see that our command here is STS test drug, and then the option comma log rank, of course, tells Stata that we'd like to use the log rank test. And then below that, we can see our attributes of our survival data that we set or defined with our stset command. Then below that, in the results, we can see that for drug equals 0, the subjects who did not take the drug, we can see that there were 19 events observed and 7.25 events expected. Then for group equal 1, the subjects who took the drug, we can see that there were 12 events observed and there were 23.75 events expected. So that gives us a chi-square, 1 degree of freedom chi-square of 28.27, and the p-value of essentially 0 tells us that we can reject the null hypothesis that the survivor functions are equal. Now in this example, we've compared two groups, but notice in the dialog box, if we go back over here, at the bottom there's a checkbox where if we had 3 or more ordered groups, we could actually compute a test for trend across those ordered groups if we wanted to. We can also test the equality of survivor functions across groups stratified by another variable. So in our example, we could test the equality of survivor functions for the two drug groups stratified by maybe age group. So let's summarize the age variable by typing sum age, SUMM, as an abbreviation for summarize. And here we see that age ranges from 47 to 67 years. And so we could create a new variable with age categories for subjects in their 40s, 50s, and 60s using the recode command. So we could type recode age 40/49 equals 1, 50/59 equals 2, and 60/69 equals 3, and then type comma, and we're going to create a new variable called age group. And then we press enter, and now if we tabulate age group, we can see that we have 3 categories of age. So if we return to our dialog box, for our test type, we can select stratified on variables, and then select the variable age group. And in addition, I'd like to check the box that says display individual test results. And now we can click submit and conduct our stratified analysis. So if we scroll back up, we can see that the command right here, the command is STS test drug comma log rank as it was before, but now we've stratified by the variable age group, and the detail option requests that we see the individual test. So here we can see the test for age group equals 1, and we would reject that the survivor functions are we would reject the null that the survivor functions are equal. For age group equals 2, we can see the results here, and again we would reject the null that they're equal. For age group equals 3, we would again reject the null. And then the overall stratified test is reported here at the bottom, and again we would reject the null that the survivor functions are equal for these two groups. So let's return to our dialog box, and we're going to check unstratified. Let's go back to an unstratified analysis, and let's look at the different kinds of tests here. There are many different kinds of tests that we could have used, and we might wonder how they differ. So to answer this question, we need a basic understanding of how these tests are calculated. With the exception of the Cox test, they're all variations of traditional nonparametric rank tests for comparing two or more distributions. They've obviously been modified to handle censored data. So at each distinct failure time in the data, the contribution of the test statistic is calculated as the weighted standardized sum of the difference between the observed and expected number of deaths in each of the groups. So let's take a look at a listing of our data to see what this means. We can list the Kaplan-Meier estimate of the survivor function using the stslist command. So if you aren't familiar with stslist, there's another video that explains it in more detail. But here I'm simply going to type the command stslist, if I can spell it correctly, stslist by drug, and then I'm going to type at 5 through 40 in increments of 5. That's what the at says there. And when I press enter, I can look in the output and I see that there's a column labeled beg total or beginning total. This is the number of people still alive at time t. It's also known as the risk pool at failure time t. The contribution to the test statistic is calculated at each time point where a failure occurs, but notice that the risk pool is actually getting smaller with time. So when we calculate our weighted standardized sum, we might want to give more weight to calculations based on a larger risk pool and less weight to calculations based on the smaller risk pool. So the nonparametric tests shown in the dialog box, let's go back to the dialog box. The nonparametric tests are all variations on the log rank test. Each test simply gives different weights to the calculation at each of the failure times. So there's actually a table in the manual here where we can see the actual weight functions used by each of the different tests. So the log rank test uses a weight of 1, so each of the calculations at each of the failure times are given equal weight. But then the Wilcoxian-Berslow-Gehan test weights the calculation at each failure time by the number of subjects in the risk pool at any given time, at that particular time. Then the Tarone-Ware test weights the calculation at each failure time by the square root of the number of subjects in the risk pool at that time. Now the Peto-Peto-Prentice test is a little more complicated. It's weighted by a modified estimate of the overall survivor function, and that's described in the methods and formulas section of the manual if you want more information about that. Then the Fleming-Harrington test is actually weighted by a function of the Kaplan-Meier survivor function, along with two parameters P and Q that are specified by the user. So we don't have time in this video to discuss how you might choose among these tests, but you can refer to your favorite survival analysis book for more information. So if we go back to the dialog box, we notice that there's also an option for Cox here. Cox test. It's not one of the nonparametric tests. It's actually calculated as a likelihood ratio test using the Cox proportional hazards regression model. But it is an option here as well, but it's not one of the nonparametrics. So let's run each of these tests and take a look at the output. We've already seen the log rank test. We're going to run each of these unstratified. So this was the log rank test. Again, we see the observed and expected events for each of the two groups. I'm going to skip over the Cox and let's look at the Wilcoxian test. Here we can see the output is essentially the same. We still see the observed and expected events for each of the two groups as well as the sum of the ranks. And in this case, again, we would reject the null hypothesis that the survivor functions are equal. Let's try the Tarone-Ware here. I'm going to click Submit. And again, the output looks essentially the same and the results are the same. We would again reject. The Peto-Peto-Prentice, I can click Submit, and again the output looks pretty much the same and our results are the same. And for Fleming-Harrington, let's just try P equal to 1 and Q equal to 1. And if I click Submit, again the output looks pretty much the same. And in this particular data set, the results are the same regardless of which of the tests we use. That may not always be true, but it is true in this particular case. So that's how we can test the equality of survivor functions across groups using nonparametric tests. I hope this was helpful. Thanks for stopping by.